Okay, this is a Geiger counter. It has in here some batteries, D-cell batteries. It generates a high voltage. And inside of here, there's a wire that goes down the middle, and there's gas inside. So whenever a particle passes through this tube, Geiger tube, it generates a pulse, an electric pulse. It goes in here and makes a little speaker chirp. Okay, so every chirp you hear is a particle that passed through. Now you might ask, why is it chirping now? Well, it's a longer story, but there are cosmic rays that come down from the upper atmosphere, high energy particles in space. They hit our Earth. Particles pass through the roof. They pass through, meters of concrete and Earth. And when they pass a cosmic ray, mu1 passes through here, you hear a chirp. So there's about one chirp per second due to cosmic rays that have always been bathed in the Earth, by the way, for millions of years. Okay? So now there are radioactive sources. For example, let's start out with, here's the beta ray source. It's a very weak beta ray source. And so in other words, there are high energy electrons coming out of here. They're going in all directions, by the way. Let me put it up here. Okay, you hear that? It's chirping at maybe, I don't know, 50 per second or something like that. I could read the dial, but it doesn't matter. Okay? All right, those are beta rays. Now, this is an alpha particle source. It's about 5.5 million electron volts. Okay? And actually, these alpha particle sources come from smoke detectors that use americium-241, radioactive element beyond uranium. Here, that's a americium-241 there, that metallic silver you see, that little spot. That's a transuranic element. It's an alpha emitter. Okay? Now watch this one. Now, you see, I'll get closer and closer. Okay? Closer and closer. You don't hear anything. Nothing special. Nothing's happening. Okay? It's going crazy. Thousands per second. Thousands per second. But notice, I back off even an inch, there's hardly anything left. Why is that? Well, that's because an alpha particle, even with 5 million electron volts of kinetic energy, only travels about this far in air. In fact, a piece of paper will stop it. So watch this. Here it is pointing up. I'll put this over it, going like crazy. Now let me put a piece of paper in between. Stopped it. So alpha particles are stopped by a piece of air. I mean a piece of paper and a few centimeters of air. Okay? And now a beta ray, however, goes through many centimeters of air. It takes a couple inches of water or maybe a couple inches of wood to stop it. Okay? So, and we can experiment with that. Okay, let's see. Let me see my hand here. Okay. Okay. You can hardly tell any difference actually. Okay. It's a very low source. Now, so now this is actually a cesium source, right? The beta source. Cesium-137 is a radioactive element. Okay. And these are sources that are made commercially and they're sold to, physics labs. They're very harmless. The radioactive substance itself is carefully encased inside. Okay. Now, this is actually a plate, a ceramic plate, bought in Mexico. So you can go down to Mexico on a vacation and you go to the marketplace and you can find these very colorful, very nice plates and many other things. And you can buy them for, very cheap and bring them home. Let's see what the Geiger counter has to say about them. Okay? It's even more than the americium alpha source, all right? It's huge, okay? All right. Again, I'm not going to try to read this. There's a meter here that tells you how many clicks per second, but we never mind that. It's very hot. So what's coming out of here? Well, first off, almost every clay lab, pottery lab, has bricks in it, and it also has glaze material. This is made largely out of thorium. Thorium oxide actually is a refractory material because it doesn't melt until you get up to 4,000 or 5,000 degrees. So you use them to make ovens with. So this thing is loaded with thorium oxide, and thorium is a radioactive element that has a huge decay sequence. Alpha, betas, and gammas are coming out all the time. That's what's coming out. Now, I would like that we can ask, what, for example, what is it that's coming out? Well, if it were alpha particles, then we should be able to see a difference when we do this. Well, the truth is, unless I'm very careful, I don't see any difference. But there must be alpha particles. I think they're actually absorbed before they get out. What about beta particles? Well, let's put this here. It's going at a certain rate. If I put a couple of inches of wood, so a lot of beta particles are coming out of here, right? Okay? Now, also coming out of here, by the way, are gamma. Gamma particles, it takes, this much steel to stop the gamma rays. So a lot of gamma rays are coming out. So what you're seeing here are gamma rays. Okay, not very many of them, primarily because this is not good at detecting gamma rays. Gamma rays will just go right through it, just like they go right through the wood here. Okay, so we know that this is mostly betas, undetectable amount of gamma, alphas, all that are there, and some gammas that we could measure if we wanted to go to the trouble. Okay, so now, so that's radioactivity. Okay, in everyday life. We could use it to measure cosmic rays if we go to the trouble, but you might find it fun to handle a Geiger counter. Don't be afraid. There's nothing. You should wash your hands after touching this plate, however. Okay, but you should feel the Geiger counter and notice that there actually are high energy particles here, atomic particles from the nucleus. All right. Now there's a certain lesson here. As I said, the alpha particles are stopped by a piece of paper. They're also stopped by the first layer of skin, dead skin on your body, okay? So if you were a white lab coat, the alpha particles are not going to hurt you. So you say, well, no problem. But the problem is that the inside of your stomach does not have a lining to it, okay? So if a chip were to break off of this plate, which can happen in a kitchen table, and you were to swallow it, it would be very serious, very serious. So that's why there's the Environmental Protection Agency, for example, puts a stamp on pottery from Japan, the US, or anywhere else in the world, certifying that it's not radioactive, okay? So that's just a small lesson. Thank you.